Hello, Algebra 1 students. Here we are back in our absolute value functions notebook, and we are on lesson 6A and B for tier 2, and we're going to check that off. And we're dealing with lesson 6A and B, which is vertexes from equations, dealing with maximum, minimums, increasing, and decreasing. The vertex of a parent function, f of x equals the absolute value of x, is at 0, 0. What this tells us is in the general form of the equation, f of x equals the absolute value of x minus h plus k, is that h and k are values of our vertex. And k is the y value, and if it's positive, it's positive, and if it's negative, it's negative. And h is a little weird because if it's negative, it's actually a positive. So in this situation, when it's x minus h, that's a positive h. And if it was positive, if it was x plus h, it's negative. Just like when we have those horizontal transformations, when it's positive, it goes to the left, and when it's negative, it goes to the right. Because anything inside the absolute value expression is opposite of what you think. So if we're given this function here, f of x equals the absolute value of x minus 2 plus 1, can you guess what the vertex is going to be? Take a second and guess. My guess is going to be 2, 1. I come over 2, up 1. I don't see any other transformations, so I know it's my slope going this way is 1, and I know my slope going this way is negative 1. Let me do a little quick table and plot it just to check. So if my vertex is 2, 1, then I want to go where I'm at 1 and where I'm at 3. Well, at 1, if I plug in 1, I get 1 minus 2, which equals negative 1. The absolute value of negative 1 is 1, plus 1 is 2. So let's check that point. I'm at 1, 2. It's right there. And input 3, I get 3 minus 2 is 1. The absolute value of 1 is 1 plus 1. That gives me 2. And that gives me 3, 2. So that gives me this point right here. So I know that 2, 1 was a great guess for my vertex. Did you guess 2, 1? Another thing I wanted to point out is unlike linear functions, absolute value functions can be decreasing and increasing at the same time. The vertex is the point where this change occurs. So if we examine our graph up here, we are decreasing from here to here, and we are increasing from here to here. And where it changes is right here at the vertex. If we know that, we can find increasing and decreasing intervals if we understand in behavior and vertexes. I look here and I know that my vertex is going to be at 1, 1. And I also know from previous lessons that this causes a vertical flip. So that makes my graph look like this with my vertex at 1, 1. I know that I'm increasing from here to here, and I'm decreasing from here to here. With that little sketch, I can tell that I'm increasing from negative infinity to 1, and I'm decreasing from 1 to infinity. And again, over here with a different function, I know that my vertex is at 1, 1, and I now don't have that same reflection, so I know that my graph looks kind of like this, with my vertex being 1, 1. So I know that I'm increasing from here to here, which is from 1 to infinity. And I know that I'm decreasing from here to here, which is from negative infinity to 1.